Hello students. This is question from NET December 2023 on statistical mechanics. And in this question, a system of n non-interacting classical spins are given, and each of the spin can be in these states, 3 states. You can see that. Okay. And that is placed in a magnetic field H. Sometimes we represent it by capital H. The single spin Hamiltonian is given by this. So this is the Hamiltonian. Now, if you go by the value of sigma, you will find that this will form a 3-level system. Suppose I put sigma is equal to 0, so it will become delta. If I put sigma is equal to 1, then also this part is gone. So it will be minus mu b h, correct? And if I put minus 1, then also this part is gone. It will become mu b and h. So essentially only this part is playing, and for sigma is equal to 0, only this delta will remain. So this is the 3-level system of energy E1, E2 and E3 that is formed. Okay. So rest of the thing we already know how to do, because once it is a 3-level system, what you will do next is you will calculate the partition function z, that is given by e to the power beta mu b h plus e to the power minus beta delta plus e to the power minus beta mu b and h. Okay, this is the partition function, and the steps are very clear. Next step is to calculate the free energy. Okay, so F is equal to minus kBT ln Z. All right. So calculate the free energy as a next step. So it will become F is equal to minus kBT ln e to the power beta mu b h plus e to the power minus beta delta plus e to the power minus beta mu b h. So this is the free energy. So from free energy, we know that dF is minus sdt minus pdv and minus m dh. H is the magnetic field intensity here. Okay. So what is the value of this magnetization? Capital M. So capital M will be minus dF by dH at constant temperature and volume. Okay. So in beta you have temperature. You should remember this, that beta is function of temperature. So if I take the differentiation and to calculate capital M, so capital M is magnetization. So capital M is given by, take the derivative with respect to h, so it will be minus kBT 1 upon e to the power beta mu b h plus e to the power minus beta delta plus e to the power minus beta mu b h. This is logarithm 1 upon, and then when you take the derivative of this, you will get in the numerator beta mu naught will come, exponential will be remain, and here it will become 0, and then minus beta mu naught will come and exponential will remain. Okay. So this is the value of capital M, and if I want this magnetization will be given by, for a small value, what you will do? So M will be equal to minus KBT. Open this. Beta mu naught is common. So take it common. Beta mu naught, beta mu naught. Okay, mu b actually. Mu b is given. It is common. And just open the exponential. Okay. So it will be 1 plus beta mu naught h. And the second one will be minus minus 1 and minus minus plus beta mu naught h, and upon similarly here 1 plus beta mu naught h plus e to the power minus beta delta, and e to the power minus will be 1 minus beta mu naught h. Okay. Now if h is small, then we have to solve this. So here 1 will cancel like this, and here this will cancel, and it will be beta and KBT will cancel. Okay. So what you get is 2 beta plus beta, 2 beta mu naught h upon 2 plus e to the power minus beta delta. This is the value we get. 2 beta mu b h upon 2 plus e to the power minus beta delta, and mu b will become mu b square also. So 2 beta mu b square h upon 2 plus e to the power minus beta delta. Correct? Now as a last step, the chi is equal to del m by del h by definition. Susceptibility is del m by del h, where h is magnetic field intensity. So in final option, if you differentiate it with respect to h will be gone, and this answer second is correct answer. Okay. So this is the correct answer, 2 beta mu b square, and h will be gone after differentiation. So you get the susceptibility as this. So this was a nice question. Just a Hamiltonian was given. First step is to write the Hamiltonian properly, and then write the, once you get the energy levels, get Z, then get F, then from F you can calculate magnetization, and from magnetization you can calculate susceptibility. So straightforward questions that I discuss in class always: how to write energy levels, then how to write partition function, how to write free energy, from free energy how to write different quantities. So this question is in the same breath. Okay, thank you so much.